Hello and welcome again to this part of tutorial in which we will study file IO. For C, there are two types of files, text and binary. C standard library gives you lots of functions to control IO, both console as well as file IO. Almost all programs do file IO. Unix systems are very peculiar in the sense that they treat everything as files. Next point says Windows has mandatory file locks while Unix has advisory. That means if you open a file in one program and you try to open the same file in another program, then Windows will not allow you that, while Unix will. Unix will even allow you to modify that file in another program. Operating systems typically put a restriction on how many files can remain open at any point of time. This limit can be overridden by your system administrator. However, since there is an upper limit, you should always close file pointers after use. File pointers are used to open file and we get the file pointer. So let's do our hands-on session. Okay. So we have here fileio.c and there are lots of functions provided by C which you can use to do file IO. So let's see them one by one. I'm commenting out this so that you can see the description of these functions. So see, remove is a function which removes a file. It is like a deletion. Rename will take an old name and rename the file with the new name. TMP file generates a new file. TMP name will produce a temporary name for file. Fopen opens the file. Fclose closes and Flush flushes any buffer to the file. Now you see there is something called mode. These are the modes. We have the modes as const char pointer. So R, W, A, RB, WB, AB, R plus and so on. For IO, we have fprintf, fscanf, fgetc, fputc. We have seen few of these. So you can uncomment these and you can see the descriptions of these, or you can refer to man pages. So let's see these in use. To declare a file pointer, this is the declaration. File *fp is equal to null. Then I open a file test.txt in R plus mode, which is for read and write. And then I check if it is not null, I print this value. Now I declare an integer I and then I seek to the beginning of file. Seek set is a macro which sets the file pointer to the beginning of file. This is necessary because after fprintf the file pointer will be pointing at the end of the file. Then I do a scanf and read the printed integer into this variable I, and then I print that. And then I again reset file pointer to the beginning. And then I try to read character by character using fgetC in the while loop, and I print that as character. Then again I reset and I use fread to read 4 bytes in one go. And ftell I have shown you to give the position of file pointer in the file. So let's run this program. Okay. So you see the first printf prints I, then in the while loop all the characters are printed, and then we have fread, and then we do putfa, and then we have ftell. These are basic functions, and if you run this program, a test.txt will be generated and will be shown here. So if you change this say to 44 and you close this and build, and again run. Okay, so this has got the old value, so we delete this because we are not rewriting it. Okay. So we build it again, we run it. So we see 44. Now you saw that we could not overwrite this because this was in R+ mode. So if you want to destroy the old content, then as you can see here, W truncates to 0 length and creates text file. And for binary file, you will have to use WB. So you should read about these functions and try to implement them one by one, because it's not possible to describe all the functions in entirety, but I'll show you remove, for example. So let's comment this out. Okay. Yes. And then we say remove. So this test.txt should be deleted now. Let's see if it gets deleted. See, the test.txt which we had is still there. So remove file name. Okay, it takes the file name, not fp. So let's comment this out, and we simply say remove test.txt, and we don't need. So we fill this and then we run this. So you see test.txt is deleted. Now similarly you can generate a temporary file and create a temporary name. Let's try to get a temporary name for a file. So I declare a char pointer name is equal, or better, okay, let's make it an array of say 32 characters, and when we say emp name, it takes a char pointer. Okay, he is not there, so we pass name, and we then try to print this name, %s, comma name. So let's see if we get a temporary name. You see, in the /tmp folder, it created a temporary file for us, and this is our file name. We need to experiment with all these functions and get acquainted with them. In our next part, we'll see the combination of file IO and command line arguments. Till then, happy coding.